Everybody, today we're going to analyze multi-layer system pavement and class objective. Simulate the condition with a computer program for multi-layer elastic system and analyze the stress, strain and deflection conditions. And here we have mechanistic concepts. The previous topics have the following assumptions. The previous topics are Alvin and Ulrich method, also Bullminster method, and one method which consider only two layers. But with a computer program, we can analyze more than 2 layers. Those methods have the following assumptions. Layer has a linear behavior. Layer is non-viscous. As you can see here in the graphic, we have time versus strain. This is the behavior of the pavement. So here we're going to analyze, as I said, a multi-layer system. Here with a computer program, we can analyze more than 2 layers. Here we have n layers. Here we have as example a multi-layer system with 5 layers, each one with for example, the first layer has 4 inches of thickness, 6, 12, and here we need to calculate the stress, strains and deflection at the following 14 points directly under the load. At 0 point, here we can calculate the deflection at 2, 4, and until 20.001 depth. Here KENPAVE is a computer program which helps us to analyze a pavement. Pavement could be flexible or rigid. In this case, I'm going to analyze flexible pavement. And here we have types of loads. For load 0, we have single wheel. Load 1 for dual tandem, which has 2 directions. Load 2, dual tandem. And also we need to provide the material properties. And this is the result of the analysis, which we can get just in a few seconds. And this is the last one, the layers. As you can see here, we have 5 layers. Here we have the loads. And finally, we're going to analyze the damage for fatigue cracking and permanent deformation using this expression, these numbers, which are empirical values. Let's start using the program. Well, here first layer, file, new, and general to provide a name. For example 1. Type of material. Here we're going to analyze linear. Damage analysis, no. Number of periods per year, 1. Number of loads, only 1. We have dual. Number of layers, how many layers you have here? 1, 2, 3, 4, 5 layers. We have 5 layers. Number of coordinates for analysis. Number of coordinates. Here we have example. We have 14 coordinates here. 14 coordinates. 14 coordinates. Okay, maximum cycle iteration 80, the same. Type response is the same. Okay, that's all. The next one is here, the coordinates 0. The second one is 2, 4, 4.001, 0, 2, 4, 4.001, 4.001, 7, 17, 10, 10.001, 1, 13, 16, 13, 16, 16.001, then 22, 28, 20, 22, 28, 20.001, 28.001, and 42. Okay, then the layer, we have five layers. That the thickness, the first one is 4, 6, the first one is 4, 6, 4, 6, 6, 4. Poisson ratio is 0.2, 0.2, 6, 6, 3, 6, 4, 6, 3, 6, 0.4, then 12, 12 for here, 12 for 0.4. The last one, is 0.45, I think is 0.25. is 0.25, 45 is 0.45, 0.45. Okay, then layer here, no modulus. Here click the first modulus, we have 35,000, 15,000, 85, no 300, 300,000, 150, 100,000, 350,000, 350,000, 150, 100,000, then 85,000, I think 85,000 and 120, 185 and 120,000. The last one 5,000. Okay. Have model is done. Load we have here's the type load 0. We're going to put 1 here. We are going to put 1, and this here is contact radius. Contact radius is 4. Contact radius is 4.23 inches, 3 inches. Then contact pressure, we have contact pressure 85. But let's see. We're going to put other, which is 80 PCI 80 PCI. This or other exam with other data. Today I'm going to put contact pressure 80 here. Here W center to center space between two dual wheels along the J axis. Thus here the distance is 13 inches. 13 inches. 0. Here number of radial coordinates to be analyzed. Here we have to analyze 1, 2, 3, 4, 5 points. 5 points. Yeah. Then the first point is here, minus 4.23. The second point 0, 0 is okay. Third one is 6.5. There one is 8.7. And here number of points to analyze was 7 points. I'm sorry, 7 points. Here minus 4.23, then zeros, then 4.23. Here is 6.5, then here 8.77, here 13, and then last one is 17.23. Okay, load modulus. I think that's all. Save as. Example 1. Save. Okay. Save. Okay. Then we're going to go here. What? Finally, we're going to analyze. We have file general down, coordinates down, layer down, moduli down, load down also. Okay, save. Then here Kenlayer. Okay, here we have graph. Here we can see the 5 layers, 1, 2, 3, 4, 5, each one with its property. For example, the thickness here 4, 6, 6, 12. This is the subgrade, and to see the results, I'm going to go to the here. Here to see the results. Here KENPAVE, and the name was practice home open. No, was other one. Sorry for that. Here KENPAVE. Is this one the result? Here, as you can see here, we have the result. Number of layers 5. See the coordinates 14, and also we have here the thickness of each layer for 6, 6, 12, and also Poisson ratios, and here the modulus, contact radius we have 4.23, contact pressure 80, and here we have the points, 14 points, I think, yes, 14 points, and here is the result. This is the result: point, intermediate, vertical. Here we have vertical displacement, which are deflection, vertical stress strain, major principal stress, minor principal stress, intermediate stress. Here to get this data, this is the deflection, this is the deformation strain in the last layer, is in the first layer. To get ET, we should go here at 2, is here horizontal strain at 2, and we need to look for a maximum strain. We have 3.84, and where the other one? And here we have 6 0.16. This, I think this is this is greater than the first one, so this is the maximum. And for the other one, for EC, for EC, we need to see the last layer. Here we can see that for EC we need to look here, which is the vertical displacement. Here, stress for vertical strain. This for deflection at 0.2. Also here we need to see the maximum deflection, and here this is EC. EC also in the last layer we need to see this one. Here is here is the deflection on the surface. Here's ET, and here at 28.001 is the EC, and the EC we can get from here the maximum at 0.28. Here 28.00 maximum can get here, and using that values and using this expression, this expression, this is the permanent fatigue cracking, this is the permanent deformation. Here's these values F1, F2, F3, F5, we can get from this table, which are empirical values, and from that we can get how many repetitions cause fatigue cracking and how many repetitions cause permanent deformation. And that's all from this video. I hope you enjoy. I hope you learned something about KENPAVE. Bye.